Welcome to Astrophiz. I'm Brendan O'Brien, and we acknowledge the traditional owners of this land and their ancient astronomical heritage. Join us as we fight for a greener future and sit down with the world's leading space scientists to see how our universe works. And right now, we're zooming over to Perth to speak with a truly wonderful astrophysicist, Dr. Elisabete da Cunha. Hello, Elisabete.
Hello, Brennan.
Today, listeners, I'm most excited to be speaking with Associate Professor Dr. Elisabete da Cunha, a fabulous Portuguese-Australian astrophysicist and a Principal Research Fellow at ICRA, the International Centre for Radio Astronomy Research at the University of Western Australia. Now, Elisabete is a highly awarded and highly respected astrophysicist who uses some of the world's most powerful telescopes, like the JWST Optical Space Telescope and the famous ALMA radio array high up in the Andes Mountains, and our beautiful square-kilometre array prototype out in the Murchison scrublands in remote Western Australia. Now, Dr. da Cunha probes the earliest and most distant corners of our universe to understand the evolution of the very earliest galaxies, and her career has taken her all over the world, and her research has taken her back to the very dawn of time. She is standing on the shoulders of giants and seeing into the heart of the universe, and so we are very lucky to have her here right now, and especially from me. Thanks for speaking with us today, Elisabete.
Thank you so much, Brennan, and thank you for that very nice introduction.
It's a pleasure. That's great. So, before we talk about your current research work, can you first tell us, please, where you were born and where you grew up, please, Elisabete? And could you tell us how you first became interested in science and space?
Yes, I'm Portuguese Australian, but I was actually born in Paris, in France. My parents were Portuguese immigrants there. And funnily enough, I was born a few hundred meters away from where 25 years later defend my PhD.
Huh.
But I'm getting ahead of myself. Yeah, so I was born in Paris and was like a city child for the first 7 years of my life. And then me and my twin brother turned 7 or around that age. My parents had to sort of decide whether they would move to the suburbs of Paris because we lived in a tiny apartment right in the city, or whether to move back to Portugal, to their hometown. And luckily for me, they decided to move back to Portugal. I'm very happy that turned out to be the case. Basically, I grew up, the rest of my childhood was in a small town in the north of Portugal with very beautiful skies, very little light pollution. And I think that's what got me interested in the night sky. And as a child, I was just marveling at the night sky all the time. And then I started reading a lot of books about astronomy, and I got really hooked from the first book where it was explaining why stars have different colors. And it just blew my mind that, first of all, I had never really noticed they had different colors. And second of all, that we can tell their temperatures from just that without touching them, things that are light years away. It just completely blew my mind and I got completely hooked. And then from then on, I was just always trying to learn more, read more books, because back then we didn't have the internet. So yeah, around age 13, I decided I wanted to be an astrophysicist, even though nobody in my family knew what that was. And I'm first generation to go to university or to finish high school for that matter. But yeah, that's what I decided I wanted to do.
Fantastic. And it sounds like your research is still blowing your mind, and it's certainly blowing everyone else's mind. So, from those early school days, you went down to the University of Porto, where you were awarded
Mm-hmm.
your honours degree in physics, applied maths, and astronomy. Then you moved back to Paris to complete your
Mm-hmm.
PhD at the Pierre and Marie Curie University. now the Sorbonne, and from there you held several postdoc research appointments in Greece, in Germany, and now in Australia. And it looks like you've made Perth your home for the last 7 years. Now, for our early career researchers listening, could you tell us how you arranged it and why you made that move from Porto in Portugal up to Paris for your PhD, where you focused on modelling galaxies?
Yeah, so I guess the thread behind all this was always following the opportunities. And back when I was doing my undergrad in Portugal, the opportunities to do PhDs and for PhD scholarships weren't that many. And, I wasn't like the top student in my class. So I had good grades, but there were so few opportunities for scholarships from the Portuguese government that, even good students that weren't the top level, it was hard to get PhD scholarship. And so at the last year of my undergrad, I started applying for PhD scholarships elsewhere in Europe. And this opportunity to go to Paris presented itself. And it was a really good project. I was very excited. I also wanted to study galaxies or cosmology. Those were my favorite things. I didn't want anything to do with, stars or planets. So this was in the topic I really wanted. So it became kind of an obvious thing to do. It was a great opportunity. It was the topic I wanted. So I went.
Fantastic. Okay, thanks, Elisabetta. So the plan for today is to very briefly revisit some of your earlier research to understand the variety of galaxies that exist. Then perhaps you can tell us about some of your favourite instruments and spacecraft that you use to understand how galaxies have evolved since the dawn of time. How does that sound like for a plan?
Sounds great.
Okay, well, let's go. First up, could we have a quick look at your PhD research to help us understand that personal research trajectory? Now, your PhD thesis focused on looking at galaxies using different wavelengths from infrared through to the ultraviolet. Now, could I ask a couple of questions here? First of all, what's the advantage at looking at galaxies at infrared compared to UV? Secondly, can you tell us in general what big questions were you asking and what problems did you encounter in your PhD that you had to overcome? Look, I'm sorry, that's actually 3 questions. Go for it.
Okay, so what's the advantage of the infrared? Galaxies emit across the whole spectrum of light. So not just the light we see with our eyes, which we call optical or visible,
Yep.
but as you mentioned, the ultraviolet, which is higher energies, all the way through to the infrared. And what happens is that galaxies are not just made of stars. We think sometimes we might think of galaxies as large collections of stars, but between the stars, there's a lot of gas and dust. So huge amounts, clouds of gas in which there are suspended tiny little particles that we call dust grains. This cosmic dust is essential for the evolution of galaxies, but can be a bit of a pain when you're observing galaxies in the UV and the optical. Because what happens is that these grains like to absorb the UV and optical light, a little bit like when there's a bushfire and you see a lot of smoke in the air and it makes the sky darken and also makes the sun appear redder. This is what happens in space. The light of stars gets attenuated and also gets reddened by these dust particles. So what happens is that the dust is hiding a lot of the light from the stars in the galaxy. So if we only look at the UV and optical, we're missing a lot of that energy because we're not seeing what the dust is blocking.
Yep.
But the cool thing is that these dust grains, they heat up and then they produce thermal emission. So they heat up and then they cool down by emitting infrared energy, infrared light. So if we look at the emission from these dust grains, we're saving that stellar light that we lost. And so we can get a better handle on how many stars the galaxy is forming, also how many stars it has, and a lot of other processes.
Cool.
And then, oh yeah, you asked me about big questions and problems during
Yes.
my PhD.
Yep.
So about 20 years ago, when I started my PhD, it was kind of the start of these large surveys of galaxies that now we are doing a lot, right? It's in the last 20 years, it's been a boom in this kind of science. We want to see how galaxies evolve, so we're doing large surveys to get as many galaxies as possible to get their evolution in a more statistical sense. But back then, we didn't have a lot of infrared instruments. So to see the infrared light of galaxies, often we have to go above the atmosphere because our atmosphere blocks that emission, just the same way as it actually blocks the UV light. So we had a few infrared missions, but they weren't very sensitive. But there was a mission coming that was being planned called the Herschel Space Observatory, which was an infrared telescope launched by the European Space Agency. And the challenge that I was given for my PhD was the following. We have these large surveys of galaxies in the UV and optical, and now we're going to have these surveys in the infrared. How do we connect that emission? How do we connect the UV, optical, and infrared emission of galaxies consistently without spending a lot of time computationally? Because traditionally, the way these things were done is either the emission in the UV and optical was separated from the infrared, so they didn't talk to each other, or you needed very complicated radiative transfer codes, which are complex computational models that would take forever to run on a large sample of galaxies. So the question was, can we make a simple model that can run on large samples of galaxies and can self-consistently model all the emission of galaxies and tell us interesting things about the galaxies, such as how much dust do they have, how many stars are they forming. So that was what I did, and I produced this code. It was quite challenging because it was the first of its kind, and so it was quite uncharted territory.
Excellent. And we're going to talk about your MagPhys code a bit later. But during your PhD, you worked in Paris and New York. Your postdocs took you to Greece and Germany and now down under to Australia. Your research tools have also been wide-ranging, but right now, what are your favourite instruments and the spacecraft that you're using to study galaxies?
Right now, definitely the ALMA Observatory is my favorite, also James Webb, but I've been working with ALMA since it started back in 2011, and it just never ceases to amaze me how deep it can go and just how sensitive it is. And we're seeing things with ALMA that we could have never seen before, and that no other instrument in the world can give us.
Beautiful. And also what we're discovering on this show is that many instruments, they start off with a certain number of capabilities and then over time they keep on getting improved and improved. So the ALMA array today could be quite different from the ALMA array 10 years ago. So that is fantastic. And that brings us up to date. Now, can we look at the work that you're doing right now? What's exciting for research scientists in your field right now?
I think a big topic at the moment is how did the first massive galaxies form? Because both with ALMA and with the James Webb Space Telescope, we're finding massive galaxies very early on in the universe, and some of them seem to already have passed the peak of their star formation, which is really intriguing. We're seeing galaxies that are a lot more evolved than we would have thought, considering how young the universe was. So it's a bit like finding a teenager where you expect a baby. And we don't really know what's happening there. So it's something that hundreds of astronomers around the world are puzzled by. And I think at the start, in the first kind of years of James Webb, there were quite a few quite sensationalist headlines about how JWC is breaking the Big Bang and all that, because it is very, very puzzling. I don't think it's that extreme. I think in order to say something as extreme as the Big Bang model is wrong, we're going to have to eliminate a lot of other plausible causes before we say that. But it is very, very intriguing. And it's really showing us that we really don't know much about how the first galaxies came to be from these big clouds of gas where there was no stars, and then they formed the first galaxies. And how exactly is that happening and how they're evolving is still a bit of a mystery.
That's beautiful, and science is wonderful like that. The questions are so exciting. Well, it's a very long and complicated road to get to the answers. Okay, look, let's do Galaxies 101 in under 3 minutes. We have heard that there are competitions around the world for people to explain their thesis in 3 minutes, but let's go to galaxies. How many different types of galaxies are there? Why do some galaxies, like the Pinwheel or the Andromeda or our Milky Way, they're so beautifully symmetrical, and some of those earlier galaxies that you've found using the JWST, they look like a complete mess. What's going on there?
All right, so Galaxies 101. So first question, types of galaxies. Well, if you look in the local universe, this is work that goes back about 100 years, the famous Edwin Hubble, and he classified galaxies. And broadly speaking, you can say there are elliptical galaxies, which are the round-shaped ones, and disk galaxies or spiral galaxies that have a disk and spiral arms in them. Then in between those two, there's a class called lenticular galaxies, which are galaxies that have a disk and a big central round part called the bulge, but they don't seem to have spiral arms. And then finally, there's the ones we can't put in any of those categories, and we just call them irregulars.
Yep.
Now, these days, in the local universe, we live in a spiral galaxy, the Milky Way, and there are a lot of spirals and a lot of elliptical galaxies. But as you look back in time to the earlier universe, this kind of classification kind of starts falling apart. The galaxy morphology is not as regular as we see in the local universe, which is the universe nowadays, and it starts sort of evolving. Galaxies are smaller, and yes, they are more messy. A lot of them are complete train wrecks.
Yep.
One of the reasons for this is that as you go further back in time, galaxies have much more gas in them than stars, and they're always colliding with each other, and this gas gets smashed around, and it's very hard to maintain a very neat disk when you have a lot of gas and a lot of mergers with other galaxies.
Look, you mentioned the ALMA array earlier. I found over 100 of your papers up on the archive server, and you've worked on so many projects using ALMA. Can you tell us why ALMA is such a powerful research tool?
Right. I'm very fortunate to have contributed to all of these projects. I am very lucky to have a wonderful collaborators, so this is definitely team effort. ALMA is amazing because it is one of the most sensitive telescopes ever built. It can detect galaxies all the way to the dawn of time in the universe, and it's not detecting the stars, it's actually detecting the gas and the dust.
Yep.
And that's important because as we go to higher redshift, gas and dust are more important because galaxies haven't formed as many stars as we see in the universe today. And we're looking at what's happening with the fuel that will form the stars in the future. It's also very good because being an interferometer, what happens is that with an interferometer, you can combine these different telescopes to make sort of a mega telescope. So the further away you put the antennas, it's as if you had a very large single telescope.
Yep.
So they're working together. So you get extremely great resolution. So you can see these galaxies in extremely high definition. And you can actually see how the gas is moving and look at the whole kinematics of the gas. So you can see the structure of the gas and the dust, and you can measure how much gas there is, how much dust there is, and so make a census of the full interstellar medium in the galaxies. And of course, combined now with JWST that can look at the stars in galaxies at similar redshifts, we live in a very exciting era where we have both of these working together, because we can see both the cold gas and dust with ALMA and the stars, and also the hot gas, the ionized gas that shines in the optical with JWST.
That is outstanding. It's astonishing. Doing forensic science at the dawn of time. That's so cool. Okay, look, let's move a little bit closer to home here in Australia. Quite a few hours' drive from you in Perth, if you head off into the remote desert and scrublands, you can find the Australian SKA Pathfinder and the Murchison Wide Field Array, which are the awesome Australian components of the huge square kilometre array, which is being expanded further as we speak. And it's already produced some beautiful science. Will you be using the SKA for your research?
I definitely hope so. I'm actually writing a grant proposal at the moment about that. Yes, it's very exciting to have the SKA almost at our doorstep here. So I definitely, I'm very excited to use it in the future. What's cool about the SKA is that it gives us a completely complementary view of the universe. Whereas ALMA and JWST are giving us the galaxies, the SKA can actually show us the neutral hydrogen, so the very basic building block of galaxies throughout the universe. And I think having all of them working together will really be an amazing tool to understand how the first galaxies came about, how the universe got reionized, etc.
Beautiful. Okay, thanks, Elisabeth. I can sense the excitement and confidence. It's growing very nicely indeed, but we know really well that science doesn't always sail smoothly, and we're very happy to put our propeller heads on for a short time. You work on a number of international collaborations on the early universe. Could you share with us some details of a particular part of your epoch of reionization research that you're working on right now that is perhaps driving you crazy or is astonishingly exciting, or perhaps it's even both?
Well, I think some of the most exciting things coming from teams that I work with are really looking at these galaxies in the epoch of reionization, which is very early in the universe when galaxies started reionizing the universe. What does this mean? The universe at the start was just neutral hydrogen.
Yep.
So atoms of hydrogen that had their electrons. And then once the first galaxies started forming and shining, they sort of carved paths through the universe because their ultraviolet photons ionized the hydrogen. That is, they took out the electron from the hydrogen. And so the universe has been ionized ever since. And this is why we can see through the universe, because if there was neutral hydrogen in our line of sight, it would be quite opaque. We couldn't see it. We couldn't see the UV light anyway. So I'm involved in several studies of these kinds of galaxies. And really the question is trying to figure out why some of them seem to be so evolved and rotating. We found one a couple of years ago called Rebels 25 that seems to be rotating quite orderly, like a spiral would be doing. And we really did not expect that. So we're kind of following these up and trying to understand what makes galaxies rotate so orderly so early in the universe, where you expect things to be way more chaotic than what we're finding, at least for some galaxies. I guess you could say it might be frustrating if you're inclined to say so, because it's like, oh, it's challenging our models of things we thought we knew. But I actually think these things are great opportunities in science. Whenever our models don't agree with the observations, that's where we have a clear path to make progress, because we know something is wrong with our models, and we know that there needs to be something that needs to be added in our understanding, in our theories, to make it match with the observations. So I think that's actually really great.
That's fantastic. I love your approach to it, where a puzzle is a challenge. It's not something that's going to drive you crazy. Now, you've also developed a very popular open source software package that you've given freely to the research community. Could you tell us a bit about your MagFizz software, please?
Yeah, sure. So, well, MAGFIS stands for multi-wavelength analysis of galaxy physical properties. The hardest part is always finding a name for these things. And yeah, it's a code that came out of my PhD work, and I packaged it to be user friendly and so that anyone in the world can download it and use it to interpret the emissions from their galaxies. So basically, what you need to give it is the emissions, so the brightness of galaxies across the spectrum in different bands, so from different instruments. And it gives you basic physical parameters such as what's their stellar mass, what's the rate of star formation, how much dust do they have, etc. And yeah, it's been quite popular because it is very useful to have a tool like this, and because it is quite user friendly. So I know that it's even used for teaching undergrads and master students. So that's really nice.
Yes, congratulations. It's great seeing your work having lots of use by young researchers. Now, we know AI is impacting on the astronomy workspace. What are you seeing, Elisabetta?
Oh, that's an interesting question. I think there could be a whole interview about this. Actually, there's been a few papers on the archive of people debating this. I think AI has its uses. It can be a good tool, but I'm a little concerned that when it's used, especially for students and in the teaching context, because I worry that it might be the easy way sometimes for students. And what I always tell my students is don't let the AI do the thinking for you. Because if that happens, you're not learning anything and you're not practicing the thinking part, which is the important part. Not to do minor code edits or language edits sometimes, sure, why not? But it really should not become people's go-to thing before they even think about things. It's quite unfortunate, and I feel like it's not even just in science, right? It's everywhere. It's kind of unfortunate to see how it's taking over the creative part of science and of arts and other things like writing and all that, when it shouldn't. Like, the we should be making machines that do the boring parts for us, and the creative parts should be the things that we humans do because we're the best at it. So it's a bit concerning, but and mostly in terms of education and a student's experience. I don't know how this is gonna go. So yeah, I think mostly I'm concerned.
Yes, I share that concern. What I think is important is to not just get the result from your research, but to understand why you've got
Mm-hmm.
that result. But yes, I agree. It's a huge topic, and I'm sure we'll be revisiting it almost every day from now on. Thank you so much.
Mm-hmm.
Now, on another topic, Elisabetta, you're a professor at University of Western Australia, but what about the nature of your non-research work? Do you supervise PhDs, or do you have other responsibilities at ICRA and the University of Western Australia?
Yes, very much. Although I think supervising PhD students, a lot of that is actual research, is just teaching them and supervising their research. But yeah, I do a lot of things around here. Like right this semester, I'm teaching a postgraduate unit about scientific communication for physicists. So this goes to the AI question. It's about teaching PhD students how to communicate effectively, how to write papers, how to give presentations, etc. Yeah, I do supervise also some master students, undergrads, whoever wants to do a research project with me usually. I have a postdoctoral researcher that I supervise as well and works in my group. And then I have other duties such as being chair of the DEI committee here at ICRA and other things like being on international committees for the International Astronomical Union, things like that.
Cool. That sounds like an incredible juggling act to me. Just keep
Mm-hmm.
all of those balls in the air. Now, back to your research work. I'm sorry. Obviously, you're also immersed in solving some of the most complex and puzzling, as you mentioned, phenomena about the early universe. Now, how do you do your best thinking? What circumstances do you usually need to swim clearly through that immense sea of data and come up with verifiable conclusions? What situations and surroundings do you use to support your best thinking?
That's an interesting. I don't think I've ever been asked that question. Um, I think, this idea that, like this picture of a scientist just, sitting under a tree and watching an apple fall and having a eureka moment about gravity, like that's not really how most of us work these days. There's a lot of grind. Most of the times, I guess it's about consistency and sticking to a problem. And the main challenge for me sometimes is actually getting just the time, but you mentioned my juggling act, and like just having the time to devote myself fully to a problem and having some deep thinking time. But yeah, and also, I do like going for a walk and thinking about problems I might be addressing, but there's a lot of trial and error and writing code and looking at plots and reading and discussing with colleagues as well. So there's not just the one thing, oh, I need these conditions to think. I mean, if I'm well rested and my children let me sleep, usually my day goes better, and I can think better. But yeah, it's not like it's very rare that there's like a stroke of inspiration. But I will say I get very inspired by seeing what my colleagues are doing, and sometimes what I really love is just having a really good old-fashioned brainstorm
Yep,
with colleagues and just with a whiteboard and just throwing ideas back and forth. That's really great, and it inspires me a lot.
that sounds like fun as well. Thank you, Elisabetta. Now, I've had a look at your research timeline and I noticed that you were working on over 20 international collaboration projects when the COVID pandemic was at its peak back through 2020 through to 2022. Now, how did COVID affect you and your family, and what was the impact on your astrophysics research, and were there lessons learnt?
Oh, that's interesting. Well, COVID, of course, affected everyone. It was a dark time. I had just moved to Perth and started my position here, and I had been traveling a lot for conferences the previous years, and that stopped. But it also happens to be when I was pregnant with my first child, and I'm not allowed to travel when I'm pregnant. So it all happened at the same time, but I would have stopped traveling anyway. But it was still quite depressing. The fact that the borders were shut here in WA, and then it was such a long time without seeing my family, and that was very depressing. And it's also, even if I don't travel, usually people come here. There's visitors in the department, and we had none of that. We were all working from home, so it was a very different experience. But yeah, luckily we astronomers are kind of used to working remotely with others. Most of my collaborators are overseas, so I'm used to doing the Zoom meetings, the emailing and all that. So it wasn't as big a change as maybe some other professions. But yeah, we kind of missed out on the conferences and all that. And people adapted. So we started having more international conferences that were held online. And that's really good. And it was, and a lot of people pointed out that people who have children, small children, and carer responsibilities already had this impediment that they couldn't really travel, and that's something I've been living since then even. So having more options for people to attend conferences remotely is actually a great thing that came out of it, and we're already losing it. People are already starting to do in-person only conferences again, so that's a shame. We should have kept that part of things.
Yes, and it's a great thing for young undergrads and graduates who can't afford to go to
Yeah.
a conference and they can still attend online. That's a fantastic outcome for
Mm-hmm.
everyone. Now, you've painted the big picture of galaxy evolution. We've looked at your early research and your most current work. We've gone all sciencey for just a little while. Would you like to tell us about some of the things outside your research that regularly brings you great joy?
Well, my family, of course. I have two small children, and they're a lot of work, but they bring me so much joy. So it's definitely number one. And then just being a person outside of science is just nice as well. I love my job, but I'm very aware to not let it be my whole life, because I think it's healthier to have other interests in life as a person. So yeah, I like enjoying the outdoors and enjoying, I go to my Pilates classes and things like that. It's just really nice, and traveling when I can. I don't do it as much anymore, but yeah, traveling the world and seeing different cultures is definitely something I love. And going back to Portugal to see my family is one of my favorite things, and also to just hang out there and eat the food and, catch up with everyone.
Fantastic. I had a terrific trip to Portugal a few years ago and visiting Lisbon and enjoying the culture there and the food and the Portuguese tarts. It's one of my strongest memories. I didn't get up to
Nice.
Porto, but next time. Okay. Now, I hear you've written a popular science book and it will be launched in Portugal in the middle of April, coming up very soon. What's it called and what material have you covered in your book? And is it in Portuguese or will it come out as well in an English edition? Okay, Elisabetta, can you tell us about your book?
Yeah, so I'm very excited about that. That was my non-work part of life for a while, where it was written on my free time, my very limited free time. So it's in Portuguese. It's called, I guess, translating the title is What's Going On Above Our Heads. And it covers everything in astronomy, really. It's a very, very thorough account of all of astronomy, as much as I could do. So it starts with, with the Earth and why the Earth is round. Well, actually, it starts even with the history of astronomy and why astronomy is important for society. And then it goes through the Earth, solar system, sun, stars, galaxies, the universe, the Big Bang, dark matter, dark energy, life in universe. It was immense fun to write. It actually reminded me at a very deep level why I fell in love with astronomy. It was amazing to revisit that sense of wonder, to try to transmit it to the reader. And this came out from an invitation I received from a publisher from Portugal. And when I first got the invitation, I was like, well, there's so many books about astronomy you can get in Portugal. Any, Neil deGrasse Tyson book is translated to Portuguese. So I was asking myself, how do I make this unique and mine, and also unique for a Portuguese language book? So I did a lot of research on Portuguese aspects of things and small Portuguese curiosities, and also what Portuguese astronomers work on, and as much as possible try to tie each topic with things that have something to do with either Portuguese history or Portuguese astronomers work. So that was a lot of fun, and I'm really proud of it. I hope people are going to enjoy it.
Fantastic. I'll keep my eye out for it when it comes out now. You've done lecturing to undergrads and mentoring and supervision of PhDs, and you've been leading research projects and collaborations, and you've done fabulous outreach on a lot of platforms. I've checked out some of your online interviews and presentations and videos. Is outreach an important part of being an astrophysicist? And have you got anything in the pipeline right now?
Yes, I think outreach is, at least for me, is a very important part of being an astrophysicist for several reasons. One, if you like to think in terms of dollars, our research is paid by the taxpayer, so it's only fair that the taxpayer knows what we're doing.
Yep.
But more important than that, I think astronomy is, I always say it's a gateway science. Everyone likes astronomy. Everyone looks up at the sky and understands that it brings out these questions in us, and everyone is fascinated by it. So we have kind of a really great opportunity as astrophysicists to reach out to the public and through our science teach people how science works, teach people about our place in the universe. And I think those things are sorely needed in today's society. So that's why I'm so passionate about astronomy. And also, I sort of try to make an effort, being a woman from Portugal, to sort of have a bit of visibility, because when I was growing up, I needed to see role models. I needed to see that this was a possible dream for me to dream, and that it wasn't like a crazy idea. And it helped that there was an astronomer in Portugal, Professor Teresa Lago, who was very famous at the time, also because she got involved in politics and all that. But she still is a reference name in Portuguese astronomy. And it helped when I was growing up to know that, oh, here's a woman who's an astronomer and she's really good at her job. So I'm very mindful of that. And in terms of pipeline, I think writing the book was a big part of my effort to contribute to outreach. So I am going to go to Portugal and do some book launching events and all that. And I'm trying to be a bit more active on social media as well, to try to reach maybe readers and have a bit of an ongoing conversation. But for now, that's all I have going on. But I'm sure there'll be other things happening, because it's just something that I like to do.
Thank you very much, Elisabetta, and I'll be pushing this recording of your presentation out into as many platforms as possible. Thank you very much. Well, the mic is all yours, and you've got the opportunity to give us your favourite rant or rave about one of the challenges that we face in science, in equity, in representations of diversity, in science denialism. That's one of my favourites. Or
Oh
science
gosh.
career paths, or your own passion for research, or that human quest for new knowledge and understanding. The microphone is all yours, Elisabetta.
It's hard to choose a rant because I have a lot of rants to go. Uh, yeah, we can do hours of me ranting. Well, I think I'm very concerned about the way the world is going today.
Yep.
I think, as any informed person is, I think a lot of the problems happening in the world right now, you could say that it's because people have forgotten how to think critically. And they are science denial. Like these days, anyone with an internet account of any sort can say whatever they want, and being an expert and having studied a subject and following the scientific method doesn't seem to count for anything anymore. It's whoever can speak the loudest and have the most followers and whatnot. And so it's really concerning, because we as societies have we accomplished so much on the backs of the scientific method, and now we're kind of saying it's actually not needed, or we don't need it, we don't believe in it. Like things that are like so basic as, saying that the earth is round these days, it's not a given fact anymore.
Yeah.
It just blows my mind, because if that's not a given fact, then of course the other things such as climate change and human caused climate change, it's much harder to prove and to convince people if they can't even be convinced of something as plain and simple that has been known since the Greeks, that the earth is round. And we are in trouble in the world if we don't stop this. Climate change is very real, and it might actually be the destruction of us. It's not going to destroy the planet, and life is going to keep going, but we might not. And a lot of other species were going to be caught up in this. So definitely, I think science literacy is a very important thing that we need to keep pushing for. And that's also at the government's level. That's like leads me to a second rant, which is the fact that everywhere in the world it seems that governments, or at least in the countries I know, but namely Australia and in Europe, you see that in the US, obviously, that fundamental science is being defunded more and more. And these days, it's all about, can you prove that this kind of science has an economic benefit or can translate to industry? And astronomy, we call this a blue sky science, right? It's fundamental questions that we've been making since the dawn of humanity. It's not always obvious, and you can't always prove to a politician that studying the first galaxies is going to have an economic benefit down the lines. And how? We know it does because historically it has. Astronomy has led technologies in other fields, including medicine, that they are used today that would not exist without astronomy. But we can't say a priori what's going to be that benefit. We have to keep being curiosity led, not dollar led. But that doesn't seem to be the way the world is going these days. And I think it's a shame. And I think it's really shooting ourselves in the foot.
Indeed. And we can just each of us do the little bit that we can to help. Okay, Elisabetta, is there anything else that we should watch out for in the near future? What are you keeping your eye on?
In terms of science,
Yeah.
definitely more observations of the earliest galaxies, but also something that I don't know much about but fascinates me is the whole field of exoplanets and JWST getting all these spectra of the atmospheres of exoplanets, and people are looking for planets that could potentially have life in them. I think that's going to be extremely exciting, and I think we are going to make progress in that search in the next couple of decades. So I'm very excited to see that.
It is very exciting, and with all of these fabulous instruments coming online, we really are in a golden age of astrophysics. Well, thank you so much, Dr. Elisabete da Cunha. On behalf of all of our listeners, and especially from me, I've had this huge smile on my face for about 3/4 of an hour now. It's been really exciting to be speaking with you, and I've really enjoyed this, and I can't wait to see your book come out and your next journey into the epoch of reionization. Fantastic, and good luck with your next adventures and all your future travels. You're taking your children to see the world, and may your career continue to evolve like a starburst galaxy. Thank you, Elisabetta.
Thank you so much. It was my pleasure.
That's awesome.
Thank you. Bye-bye.
Thanks for listening. And remember, Astrophiz is free, no ads, and unsponsored. For transcripts and full show notes, visit astrophiz.com. Find us on SoundCloud, Apple Podcasts, or your favourite platform. Don't forget to join us on the 1st of each month for Dr. Ian Musgrave's Sky Guide and the 15th for our next interview. Clear skies. Keep looking up. Radio Wave!